Hey, welcome back again. So, last time we got to the stage where we can smash holes in things and we're popping that debris chunk out. It's a nice chunky piece of debris that we're getting. It's got physics on it, etc., etc. This time we're going to look at breaking that debris up into separate pieces. Now, I keep saying there's no right or wrong answers to what we're doing here. I want to really double down on that today because we could do this in so many different ways. One thing we could do is we could take our big old debris piece here like this, and we could actually just do what we've already been doing, which is make a shape and then boolean it. So we will probably want to do something like take a cube like this, and you'd want to position it so that the top line is covering the middle of your thing, and then you would want to add Perlin noise to it, and you'd get something like this, and you get like a really crunchy kind of break like that. I've already tried this, and it's cool, but it's very system intensive to the point that it stopped kind of being fun, and it's also a bit too messy. It actually just got a bit over the top. So I'm just going to use a plain slice this time. This is going to give me a chance to show you a different node that we're working with as well. So let's go back to our debris. And, well, let's add a comment here so this is still nice and tidy. We're going to want to duplicate it, and we're going to make more debris components. Again, it's worth mentioning that you might want to actually spawn different actors at this point. You might want to have multiple debris actors, or you might want to have maybe even have your debris pieces be destructible meshes in themselves. I don't want to do that, but you could. The thing is, we know we're going to duplicate this debris mesh component, and we're going to have to do this part, setting up the mesh and adding radial impulse every single time. So let's highlight all of this and collapse it to a function. So anytime you've got stuff that you're going to use more than once, really handy to collapse it all to a function. We'll call this set up mesh and add force, and then I'm going to go in here because this is set up to do all of this on the dynamic mesh component. I'm going to say inputs, add a dynamic mesh component. So this will let us take in a dynamic mesh component into our function. Incoming dynamic mesh component, and then we don't actually have to pull. I could pull this off the pin here and connect it, but when you have an incoming thing within a function like this, you can actually just grab it like any other. Get incoming dynamic mesh component. There we go. That in there, and then there, and then I can delete this, and then over here let's do the same thing, but let's Control C and Control V. There's our dynamic mesh component. Just copied and pasted it from over there. Okay, and when we go back to our debris here, right now we just want to take our dynamic mesh component. Nope, don't set it. So when we come here, we just want to take our dynamic mesh component, get it, and plug it into that function there. So we've got this, we've tidied this up, we've collapsed this to a function, and now we want to slice our dynamic mesh or cut our dynamic mesh. It's hard to get the terminology right. it's actually cut dynamic mesh. That's what we want to do. So I'm going to make this, I'm going to call it cut dynamic mesh. I know it sounds weird that I'm being picky about naming, but I'll show you this in a second. So this is a function that we want to make anytime that you're doing something. Remember, we talked about system design is trigger, process, and output. And anytime that you're unsure exactly what the trigger is going to be, or you think there might be multiple triggers, or you want something to be flexible, some part of the process to be flexible to have multiple triggers, it's a really good time to put it in a function so that that function can be reused in multiple situations. So we're going to get this cut dynamic mesh. We're going to bring in a dynamic mesh component, and I'm going to call it mesh component to be cut, so it's nice and specific, so we know exactly what we're doing with it. We're not going to confuse it with anything else. We're going to get the dynamic mesh from this, as we normally do. I'm going to promote this to a local variable, so we're saving everything within this particular function. Let's call this the mesh to be cut. Now, we want to make two dynamic meshes. So let's add a dynamic mesh component. I'm going to promote this again to a local variable, and I'm going to call this cut mesh component A. Fix my spelling here. Cut mesh component A. Now, as we've done before, we want to copy mesh to mesh. Now, what we want to do is we want to get this dynamic mesh. Probably see where we're going to go here. Promote to local variable. This is cut mesh A. And then we want to copy mesh to mesh. We've done this before. And again, it's going to default to from. We want cut mesh A to be the to. We want mesh to be cut to be the from. Now, we get our to mesh, or we could just get them a reference here, but we're going to use this. Here's where it gets interesting. So there's a couple of different nodes you could use here, and I'm going to type in slice just so you see. So apply mesh plain slice. It sounds like the right thing to do. There's a hint I can give you here. If you open up the options, you'll see what this does. And you see it talks about gap width. The reason it's saying gap width here is that what this is going to do is it's going to take in your mesh here, and it's going to apply take out a slice. So it's got a width that you can define for that slice, and then what we're left with is both sides like this. And that's not quite what we want. Let's delete that. So let's get the copy to mesh again. And if we type in cut, you'll see apply mesh plain cut. Now if I go into make options, you've got flip cut side. And that's because what cut is going to do is take your mesh, it's going to apply a plane like this, and then it's going to cut one side of the plane out completely, and that is what we want. So it's going to apply a plane mesh cut, a mesh plane cut to cut mesh A. Now, technically we could use a function here so we don't have to repeat code, but what I'm actually going to do is I'm going to put sequence in here. So we do this once, and it'd save me recreating nodes. I'm going to Control C, Control V, and then this is all using the same variables, which I don't want to do. I'm going to promote this to a local variable again. So now, let's walk through this. We're creating a second dynamic mesh component, promoting that, and I'm going to call that, you can probably see where this is going, cut mesh component B. Plug that in there, make sure that's connected. We get the dynamic mesh from that, promote that to a local variable. Put that in our copy to mesh, rename it to cut mesh B. And then when we come down here, we flip the cut side. So we now have cut mesh A, which is going to be 1/2. We've got cut mesh B, which is going to be another 1/2. And so we'll do a third thing here. We'll return, add a return node, so we go back out of our function. And I'm going to take cut mesh component A, and I'm just going to drop it onto here to say, call it. They always have to have a different name in the output. So returned mesh component A. Let's get cut mesh component B. Let's do the same here. Returned mesh component B. So we've just done all this. Can we spot the error before I go in? Yeah, I've not defined the position for the plane cut. Now, again, let's think this through. We've got our mesh piece here. And what we did when we were positioning the force was we used the tool component position here. And this will work. But remember I was saying before, we're thinking about flexibility and reuse here. So after, let's just a little preview of where we're going. Like, let's say after we slice this, we want to slice this again. If we slice this again in the same position, we're not really slicing it anymore. So what we actually want is to get this mesh. Let's type center here, and we get mesh volume area center. That actually gives us the center of mass of this. So we split this, and then we put this in here. And again, I could have recorded this bit, but it's a bit disingenuous, I think, to show you stuff happening like perfectly every single time. I don't want you guys to get confused, but I do want you guys to appreciate that not everything is figured out in a linear fashion. So there we go, center mass of this. And now if I go back here, we go cut dynamic mesh. And we're going to put our standard usual dynamic mesh component in here. And then what we're actually going to do is delete this. We actually want to destroy the original component because we don't want the original component anymore after this. And then we want to set up mesh and add force on returned mesh component A, and we want to set up mesh and add force on returned mesh component B. Okay, we go back here, we shoot, and it's now producing two pieces when we do this. Now, yeah, it's kind of cool, but let's see if we can make it a little bit cooler. So let's see if we can do this a number of times. Okay, so we're going to try making another function that's going to wrap up this cut dynamic mesh function. So we're going to say multi-cut dynamic mesh. Now, you could do this any way you want. again, there's just so many options at this point. What I'm going to do is I'm going to set this up so that this runs a number of times. Cuts to be made, and each time it makes a cut, what it's going to do is it's going to take all of the meshes that it has so far and it's going to cut them in two. So we're going to get an exponential number of pieces with each cut. This might be why I said this whole thing is way too system intensive, but you know, we're just having fun here. So we're going to set up we need a for loop here that's going to run this number of times. Now, old programming tradition, -1, because our index is 0, our first index is 0, and if we only want it to run once, then it should run once, and our last index would be 0. So our last index is the number of loops we want -1. What we want to do is within each of these loops we want to run through all the meshes we have. So we would be storing these meshes in a local array of dynamic mesh components. Okay, so let's make that an array, and let's say this is meshes to be cut. And then before we start, let's set meshes to be cut. So we need a mesh to start with. Let's bring in a dynamic mesh component. Let's call it starting mesh component. And we are going to make an array which only contains that starting mesh component. Okay, so what we want to do now is we want to go through this array that we've made of meshes to be cut. And so for each loop, and I'm not going to hook that up just yet because I'll show you why in a sec. So we take the mesh to be cut from the meshes to be cut array, and we're going to cut our dynamic mesh, and then we're going to destroy this, which I'm not a huge fan of destroying components within a function, like, because this is going to include the component that comes in to this function, which is, I'm a little uncomfortable with destroying stuff in a function that comes from out with that function, but I'm going to live with it today. Now, we need to store these somewhere. The problem is if we store these in meshes to be cut, then as we're running through the mesh, as we run through the loop, we're making the loop bigger, and that's just going to be an endless loop. So we need a second array of dynamic mesh components, and we're going to call this meshes to be returned, because on the last loop through here we're going to return all these meshes. Now add these to our new array. So mesh component A, and then we add, this is getting messy, add mesh component B, try and make sure that it's all visible, it's not too messy, and then once we're finished, we want to set meshes to be cut to be equal to the meshes to be returned. Now the reason I didn't hook this up over here is because the next time we go through meshes to be cut, we are going to destroy both Like if you imagine we went through this once, this is our incoming dynamic mesh component, and then we destroy it, and then we add these two here, and then the next time we come through, we run this twice, and we destroy what was mesh component A, and we destroy what was mesh component B, and so meshes to be returned kind of needs to be reset on each loop. So let's set meshes to be returned to be empty, or let's actually do this the proper way. Clear this array at the start. Okay. So clear the meshes to be returned, run through all our meshes to be cut, split them up, set the meshes to be returned to be meshes to be cut next time, if there is a next time. If there is not a next time, we go down here, return, meshes to be returned, and we spit that back out. I'll call this returned mesh components. I did mix up mesh components and meshes there slightly. I'm going to leave it for just now. So now, what we can actually do is we can actually just delete all of this and put in our multi-cut dynamic mesh. Drop this in here, plug this in here. So we're going to multi-cut this dynamic mesh component. Now that dynamic mesh component is going to be destroyed in this function. Let's set the cuts to 1, so it should look just the same as before. We should still get 2 out. And then we do it for each loop here. So for each of the returned mesh components, set that mesh up and add force. So this should give us 2 chunks just like before. There we go. We should be able to do 2 cuts, and we should get 4 chunks. And we do. That's kind of cool. Not as chunky as I like. So I'm going to do one last thing here, which is I'm going to go into multi-cut dynamic. In fact, I'm not going to do multi-cut dynamic mesh. I'm going to do into cut dynamic mesh. It's always doing, we haven't added anything to this, so it's always getting this, and then it cuts these in half, and then it does this and this. And that's kind of plain. So let's in here. Thing is, we need both of these to be identical so that we get the same on both sides. So let's add a new local variable. It's a rotator. It's a single rotator. We don't need an array of rotators. And we're going to say random rotation. I'm going to set this here. I'm going to say give me a random rotation. Random rotator, hell yeah, give me roll. And now we've got some slightly more random pieces. Now, I mean, it's not great. You know, you saw that base piece there was getting sliced like this way. But hey, we're making more debris. We're breaking stuff, and that's cool. And so this is like a whole new bunch of stuff we've just learned to do. We're almost done, I think, with everything that I can show you how to do. We just have this one problem left, which is something that really bothered me quite a bit. And that's this piece here that you can see is floating in space. And that seems like a huge problem at first, but when you think about it, like everything else that everything I'm trying to do here is, yes, I'm trying to show you geometry script, and yes, I'm trying to show you how we can use it to destroy meshes. I'm also trying to show you how none of this from a system designer's point of view, is actually that complicated. It's just the application of logic and puzzle solving, essentially, to the problem that we have in front of us. The next step is going to seem kind of complex, and I'm going to be quite honest, it's something I'm still working on myself to try and improve and make it as flexible as I want it to be. But it is just taking the tools from the API, figuring out the steps, figuring out the positions, figuring out a bit of the maths and things, and figuring out how we calculate what it is that we want in the end. So, thanks for following along. I hope you're really enjoying these. I hope you're learning stuff from it. If you do anything cool with this, let me know in the comments. Otherwise, the whole like and subscribe thing really helps out the channel. And thanks for watching. I'll see you in the next video.